So in this task, we are going to perform all these operations using doubly linked list. So for that, what we are doing is we are giving each element of the doubly linked list as list of integers. So the first head is going to be this list. The second is going to be the sorted list. The third node is going to be a reverse list, like that. So let's go back to the code. So the head of the doubly linked list is going to be a list. So we are adding all these numbers in a list and then passing to the linked list processor. So let's check the linked list processor. In the linked list processor, doubly linked list, each node of the doubly linked list is list of integers. This is the present state and the total number of states. So what we are doing in the constructor, we are creating the head and the present state is incremented to 0. The total number of state is 1. The current state is the function is to print the current state. So let's say here the current state is 0. So data in the doubly linked list, we are going to access that node, which is list, and that list will be each number from that list will be accessed, and we are going to print that over here. In the sort function, again, we are going to fetch the present state. So now the present state is 0. New date, we are going to sort that list. The list is fetched and then it is assigned to new data. The new data is sorted using collection sort function. It's an inbuilt function. Then present state is incremented by 1. The total number of state is incremented by 1. The present state is now 1 and the new data is the sorted list that we have. Using the current state, we are printing that list, which is here, sorted list. You can just run the program again. So here is the sorted list. The second is reverse. It's same as sorted. Instead of collections sort, we are using collections reverse function. The rest of the function is same. Append 9. So append 9, we are accessing the state. So now here it is 0, 1, 2. So we are accessing the second state. It is accessed array list and it is assigned to the new list. In the new list, we are adding number 9. And then again, present state is incremented by 1. Total number of state is incremented by 1. And we are saving this list as next node of the day of our doubly linked list. So now we have saved this list as state node 3. Now we have to go back to the instruction is undo back to your before the reverse list, which is sorted list. So this is node 1. We are at node 3. So from node 3 to go to node 1, we need to go 2 nodes back. So we are calling here function undo by 2. So in the undo, we are just reducing the present state by the number of states we want to go back. So here we'll be reducing that by 2 and this list is printed. Again, now we are at state 1. We are adding 9, same as we did here. So in this state, the 9 is added. And then we have to go back to the original state. So here we were at state 1. Now here state 2. To go back to original state, that is node 0, we need to reduce by 2. So now again we are calling undo function to go 2 steps back. And using that, we are accessing the head node of the doubly linked list. The next task is to check if the given word is a palindrome or not. So from the text file, we are fetching we are accessing the words and we are going to check if the given word is palindrome. So the logic that we are using the push and pop operation of the stack. And to implement stack, we are using single linked list. So this is our empty stack, this first. Second, we are taking this word, let's say race car is our first word to check if the palindrome or not. So the first half of the word, first we are going to check how many letters are there. If there are odd number of letters, the middle letter, we are going to skip that. So the first half of the word is we are going to push at the top of the stack. So R is, here we have pushed half of the word to the top of the stack. E is skipped. Now we are going to do the pop operation. So the second half of the word, we are going to compare each letter at the top of the stack. So C will be compared to the top of the stack, which matches. So C is removed. Now A is compared to the top of the stack. A matches here, so A is removed. Now R is compared with the top of the stack, so R is removed. Now what we have towards the end is the empty stack. It means the given word is a palindrome. Let's say consider word morning. So if we, here is the empty stack, we are pushing the word to the top of the stack. Half of the word, we are ignoring N, and then I is compared to the top of the stack, which doesn't match with R. So here program will return false and the given word is not palindrome. So to execute that, here the input is a word which is a list of characters. So we are going to check the size of the word and then we are check if it has the middle character or not. So this is the function we are using to check the middle character. Then here we are pushing the half the word to the top of the stack. If the middle word is there, we are going to skip the middle word and the remaining half word is compared to the top of the stack. If it is matches to the top of the stack, we are going to delete the word at the head top of the stack. If it doesn't match, then program is going to return false. And if it matches and the word is over, we are going to compare the length of the stack. If the length of the stack is 0, it means the given word is a palindrome. If not, it means the given word is not palindrome. Here are the results that we have.